Good morning, boys. Welcome to today's lesson. We are looking at algebraic expressions. It's going to be a very quick, very easy lesson. Hopefully I'll keep these under about 8 minutes. So a couple of things, as you can see on the board here, we have a nice algebraic expression. I wonder if you can remember what that means. An algebraic expression is made up of a number of algebraic terms. In this case, we have, I believe, 7 terms. So we have 7 algebraic terms which are made up of different variables. Now remember, the x's are what we often call variables, or sometimes known as pronumerals. And sometimes we have pronumerals that are the same, and that's what we refer to as like terms. So can you find any like terms in this particular expression? Well, hopefully you can see that we have the 2y and the 3y. They are both like terms. Now, if we plus those together, we could actually say that that would equal 5y. And you might remember back in year 8 and year 9 that we would add and subtract like terms. You also might notice we have this xy and yx. And hopefully you remember that xy and yx are also like terms. Now, if you think about it, they're being multiplied together. So let's say, for example, we have 5 and 3. 5 times 3 makes 15. 3 times 5 makes 15. They're both the same thing, so it doesn't matter which way they're around. So if we added x, y, and yx together, we would have 2 lots of xy, or in fact, you could say 2 lots of yx, but we tend to put the alphabetical order where we can. Now, you might remember the plus 7 at the end has a special name as well. Now, although there is no algebraic kind of pronumeral attached to it, or variable, we still do identify that as an algebraic term. You might remember if we have something like 7x to the power of 0, anything to the power of 0 equals 1, therefore this actually means 7. So we still call it an algebraic term even though there is no pronumeral attached to it. This is what we refer to, if you remember, as the constant term. Now, why is it constant? Well, if we were subbing values in for the x's and the y's, etc., there's nothing to sub into of that last term. Therefore, it will always remain as a 7, therefore being constant. And probably the other thing I want to talk about would be the numbers in front of the letters, and they are called the coefficient, or the coefficient. So, for example, the coefficient of x would be 3. The coefficient of, let's say, the constant term would be 7. The coefficient of the y's would be 2 or 3. Now, the other thing I might mention before I move on is the difference between the x and the x squared. I did not say that they were like terms because they're not. Now, why are they different? Why are they not the same? Well, x is just, it's just an x, right? And x squared, well, that actually is x times x. So let's say, for example, x was 10. You'd have 10 here, and you'd have 10 times 10, which would be 100 here. Therefore, if I had 2 x's, well, I got 2 lots of 10, that makes 20. If I have 2 lots of x squareds, well, I now have 200. So you can see how these are completely different terms. Even though, yes, they do contain the same letter, okay, the squared means that there is more of them being times together. So they're not the same. So again, important things for us to remember. What does a pronumeral or a variable mean? What is a coefficient? What is a constant term? And what are like terms? That's a real brief review, I guess, of year 8 and 9 algebra. Okay, can you remember some of these words? Remember, at any point in time, pause this, write the examples down, and then have a go at them yourself, and then you can play it and see if you got it right. Okay, what'd you get for 2 more than a number? Well, I'm going to say y add 2. So for example, if the number was 10, it'd be 12, because it'd be 10 plus 2. If it was 20, it'd be 20 plus 2. Either way, we're simply adding 2 to whatever that letter or that number might be. Now, it said a number, so I let y be any number. You could have said x plus 2. You could have said q plus 2, whatever floats your boat. Okay, what about the next one? 3 less than a number. Well, I'm hoping you've said, very similar to the example 1, y subtract 3. Now we've got to be very careful here. In that first example, we could have actually rearranged that and said 2 plus y, for example. That's the same thing because they're both positive numbers. The problem is, if I say 3 minus y, now I have a negative y, not a positive y, and they are different terms, and only one of them is correct. So if you think, what's 3 less than 10? Well, that would be 7, right? Because you do 10 minus 7. What's 3 less than 5? You 2. 5 minus 3. Okay. Now, either way, okay, you can see how we're taking the number, whatever the letter might be, okay, and we're subtracting that 3 away from it. So that's why I've got the y subtract the 3. Okay, what about, this will test you, quotient. The quotient of a number and 5. Well, a quotient of any number, let's say we'll call it Q in this instance, and 5. Well, what does quotient mean? Well, hopefully you might remember, quotient means divide. Now, the only issue here is, in mathematics, we don't see the divided by symbol as being simplified. So if I had it on its own, what we want to do is rewrite it with a fraction. I know it sounds strange. Why do we do it? Well, who knows, but certainly that's what we do. We write it as a fraction. It's simplified. So in examination, gents, that would be the only accepted answer that we actually give for a simplified response. So there's some special words for you to remember, and these are some things you want to write down your notes. What does the product of two numbers mean? Well, this is when we are multiplying or we are timesing, okay? What about twice? Well, that means double, right? Or that means 2 times a number. Triple, well, that means thrice, okay? Or 3 times a number. What about the sum of two numbers? Well, the sum means plus. The difference of two numbers, well, that'd be subtract as well. So you can see that these are some special, words that mean some type of mathematical symbols that we have to know the difference of. And then the very second last one, nearly finished. We'll try to get this under 8 minutes. 3 times 2 more than a number. So can you rewrite this as an algebraic expression? Well, 3 times means 3 in a multiplication symbol, and it says 2 more than a number. Well, 2 more than a number, that would be something like, let's say y plus 2. But we have to be really careful here, because if I leave my answer like that, right, then BidMath says I'm going to times the 3 and the y together, which would be 3 times a number plus 2, which would be different to what they actually asked me. It said 3 times 2 more than a number. So I need to put brackets around that 2 more than a number, and now I can times it by 3. Now, of course, we could write it without the time symbol and have it as 3 outside of y plus 2, or in fact, you could even have it as 3y plus 6. And my very last example, okay, is a bit of, can you remember what this is called? Substitution. So in this instance, what we're looking for, we're replacing or substituting the letters with the numbers. So in this case, we have 2 times a times y. So let's replace the a with a 3. So 2 times 3 and the -7 with the y. And I can do it on my calculator or hopefully in your head. 2 times 3 is 6, 6 7s are 42, and it's a negative, so it's a -42. Okay. The next one, we have 3a subtract y. Well, same thing, gents. I'm going to simply remove the a out and put a 3 there. You could say 3 times 3, or I could even put brackets like that. And then I'm going to put a minus, and I'm going to put my -7 in. Now, this one's a bit trickier because you're going to have 2 double negatives here. 3 times 3 makes 9. A minus and a minus, well, they're directly next to each other without anything in between apart from the brackets. So I'm going to put a plus there. 9 plus 7 is equal to 16. Wonderful. And the very last one, I'm sure you'll get this one wrong, but I have faith in you. Y squared. Well, this means -7 squared, which means -7 times -7. And that, of course, makes a positive 49. Remember, unfortunately, gents, if you put it into your calculator like this, your calculator is smarter than you. It will square the 7, but not the minus. It will do the BIDMAS first, the indices. So we need to put brackets around that -7 to tell our calculator to square both things. Gents, I hope this has been a little bit useful to you. Please go back and have a look at the questions that I've set for today. Hopefully, if you have any issues, you can maybe email me. Apart from that, have a wonderful day.